Welcome back. Now that we've covered all the basic ideas for this section, we're just going to put them into practice with some examples. Let's start off with this first one. We've got 11 different math books, I've got 14 different physics books, and I'm making a selection of 7 of them. Notice I'm not going to take those books and arrange them on a bookshelf or give them away to particular people. I'm just selecting books, so this is just a case of selecting objects, not arranging them. I should just have combinations involved for this kind of a question. Okay, first part is asking how many ways are there for us to do this selecting if we have no restrictions. And so if we have no restrictions, then we're going to take out of the 25 books in total just some collection of 7 of those books. And so the number of ways to do that should be 25C7. So for this one, relatively quick. I don't even need multiplication principle or anything else. It's just a simple combination. Okay, let's move on to B. We have exactly 3 math books being selected. And for that, we have to remind ourselves if I'm selecting 3 math books, that means I'm also selecting 4 other books to get my 7 books in total. So if 3 of the books are math, then that means I'm also selecting 4 physics books. So now that means I've got 2 tasks to do, so multiplication principle, I'll need it now, because I'll need to select 3 math books and I'll also need to select 4 physics books. There's 11 math books, so 11C3, that's the way to choose 3 math books, and 14 physics books, so 14C4, that's the way to choose 4 physics books. So we've chosen 3 math and 4 physics. That's our 7 books in total. So 165,165 different ways for me to select exactly 3 math books from that collection of 25 books. Okay, one that's an even tougher question now. Now, it's not just exactly, it's at least. I want to know what's the number of ways to get at least 2 physics textbooks. So if I start by looking at this directly and say, what if I wanted to compute the number of ways to get at least 2 physics books? I'll have to think about what that means exactly, at least 2 physics books. Well, that would mean having 2 or 3 or 4 or 5 or 6 or 7 physics books. So hopefully you heard me say the word or over and over. That's really pointing at that if I wanted to do it this way, directly, I'd have to think about using inclusion-exclusion, because either I would have 2 physics books, or I would have 3 physics books, or I would have 4 physics books, or all the way down the road until I get to 7 physics books. So if I wanted to do this directly, I could. It would be the number of ways to get 2 physics books, plus the number of ways to get 3 physics books, and plus until the very last one, number of ways to get 7 physics books. Now we could finish this off and we would do it much the same way that we did the last question. So for each of these parts, 2 physics books really means 2 physics and 5 math. 3 physics books really means 3 physics and 4 math. And I could use the multiplication principle to figure out each of those 6 separate little things and add them all together. But I think it's good to take a moment to ask if there's an easier way. And so I'm going to think about using the complement. So here, if I'm thinking about using the complement, I would say instead of looking for the number of ways to get 2 or more physics books directly, we'll just take the universe and then get rid of the things that we don't want. And in this case, what we don't want would be having 0 or 1 physics book. So really there's 2 things I'm going to need to remove from the universe. I'm going to take all the possibilities and I'm going to remove the ones where there's no physics books. And I'm also going to remove all the possibilities where there's exactly 1 physics book. Now, if you compare the workload, the previous way of doing it would have us calculate 6 separate things and then have to add them all together. That's a lot of work. Here, we only really have to find 2 things, the number of ways to get 0 physics books and 1 physics book. We already know how many things are in the universe, because that's the number of ways to do our selection with no restrictions. So I'm going to actually choose to use counting the complement. So I will use this second approach. This is the easier way for me. So 25C7. And now for each of these, we have to think about the same way that we thought about before, that if you're selecting 0 physics books, you're really selecting 7 math books then. So you could say that out of the 11 math books, let's select 7 of them. If you wanted to, you could also add in a second task that out of the 14 physics books, selecting 0 of them. But the number of ways to do that is just 1, so you don't really have to mention that. So you could just say 11C7, and therefore you've selected all the 7 things. You don't really have to think about there being a second task. For the second one, when I'm having 6 physics books, that's 6 physics and, 1 physics book rather, that's 1 physics and 6 math. So that will need 2 tasks. 1 physics book, 14C1, and 6 math, that's 11C6. And then I would just need to compute this, and I'd find 473,902. Now, if you wanted to, you could tackle it the original way. So again, each of those you'd have to think about using multiplication principle. So for example, for 2 physics books, that's really 2 physics books followed by 11 C5 for selecting 5 math books. Or 3 physics books followed by selecting 4 math books. 4 physics books with 3 math books. 5 physics books with 2 math books. 6 physics books with 1 math book. Or the last option, 7 physics books and 0 math books. Now, if you wanted to, you could compute for yourself this expression that I've got up top, and you'll find that it's actually equal to exactly the same answer that we had below, that 473,902. This is another example of where somebody's answer might look different. So, for example, you might have come up with this as your solution, and the answers to the practice questions might look more like this. Again, you are not necessarily wrong. You really should just compute things and see, does it actually turn out to be equivalent? So here we have 2 different ways of tackling the same question, one very much faster than the other though. So good advice always for these sorts of questions. Take a minute to ask yourself, would the complement help? And if it does, then definitely you should make use of it. All right, let's do another example. This time we are traveling. We're going from home to school, and then the plan is as we're traveling, we're going as directly as possible. We're not allowed to go backwards. So as I leave home, I couldn't do this sort of a move where I go east, then north, then west, because now I'm traveling backwards. I would never be able to allow to do that. I couldn't do something where I go north for a while and then go back down to south, because again, that's backtracking. We don't want to do that. So on this grid, we're only traveling north or east. That's it. Those are the only options available to us. So before we get into the counting side of things, maybe it's worthwhile to take a minute to try to write out some possibilities, some sorts of ways that you could go from home to school. So, for example, one pathway might be this one. And that pathway has me going north 3 times and then east 4 times. So if you wanted to describe that pathway to me, you'd say, go north, 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 then east, 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 east. That would describe the first little pathway that I drew. A second pathway might be, there we go, here's another one. And this one has me going east twice. And then I go north. And then I go east 2 more times, and then I go north 2 more times. That's another way that I might travel from home to school. I'll do one last one. Another way to go from home to school might be this path that has me going east 4 times, and then north 3 times. So the one thing that I want us to notice here, and this is all my basic analysis that I'm doing before I start thinking about the actual counting. For this story, any way that you go from home to school, you could think of it as 7 different movements. You're going to go north 3 times, and you're going to go east 4 times. So you'll notice for each of these, there's 3 N's and 4 E's. For the other way of getting to school, there's also 4 E's and 3 N's. For the other way of getting to school, there's also 4 E's and 3 N's. So the idea here is that if we're thinking about finding all the different ways for me to get from home to school, what we're really doing is we're arranging 4 N's and 3 E's. So, or 3 N's rather, and 4 E's. So that's actually not too hard to do. We have 7 things and we'd like to arrange them. Now I'm going to caution us. I know some of us might be thinking 7 factorial will be the answer. But remember, factorials can only be used if we're thinking about arranging things that are distinct, that are different from each other. And in this case, the n's are all identical to each other, and the e's are also identical to each other. So sorry, 7 factorial won't be the answer for me. So what I'm going to do here, I'm going to just draw 7 little spaces. 1, 2, 3, 4, 5, 6, 7. And if I were thinking about arranging these 7 letters, the 3 N's and the 4 E's, I could really do that just by answering one question. I need to ask myself, which positions are going to be the ones where the N's are? So I might say to myself, well, there's 7 different positions and I need to select 3 of them. So 7C3, that would be the number of ways for me to choose where to place an N. So I might decide, okay, I'm going to stick an N here and here and here. Once you've decided where the N's need to go, you don't need to choose where the E's are going to go because you've got 4 leftover spaces, and I guess those 4 leftover spaces are where the E's will go. So really, when it comes down to arranging these 7 letters, 3 N's and 4 E's, it really just boils down to one question or one task, which is out of the 7 places, choose 3 of them to have an N. And that would give you 35 as the number of ways to make that arrangement. You could have also asked yourself instead of asking which 3 places have an N, you could have asked yourself which 4 places have an E. And in other words, you'd be choosing out of the 7 places, 4 of them to place an E into, but that's also equal to 35. So it really doesn't matter. Either way, we could arrange our 7 letters by asking ourselves, let's find 3 places to put in an E, and then everywhere else, 3 places to put in an N rather, and then everywhere else will be an E. Or we could ask ourselves which 4 places will have an E, and then put N's everywhere else. Either way, there'd be 35 ways to make those choices. So that means there's 35 different ways for me to get from home to school if I'm just going only north or east.